All right, y'all, I just wanted to create this short video and talk about the multiplicity of roots and what that means. What does the word multiplicity mean? Because we're going to use that with the fundamental theorem of algebra. So I wanted to introduce that word in the following examples. So we have two quadratics written up here, written in factored form, if you remember. So let's first find the roots here. All right, to find the roots of this polynomial, we set it equal to 0. Then using the zero product property, we would set each factor equal to 0 and solve each equation. So we get x is -1 and +1. Now, the multiplicity refers to how many times that solution shows up in the solution set. Or another way to say this is how many times that factor appears in the quadratic. So if you look at the factors, there's one factor of x plus 1 and one factor of x minus 1. Therefore, the solutions corresponding to those factors only appear one time, because there's only one factor of each. So we would say that both of these have multiplicities equal to 1, and same thing here. All right, now, if I were to sketch this function, all right, and this is really where multiplicity comes into play, because the multiplicity tells us the behavior of the graph around these roots or around these x-intercepts. So let's take a look at what the graph of x plus 1 times x minus 1 would be. All right, well, we know it have x-intercepts at -1 and 1. Okay, since it's quadratic, we know the shape is going to be a parabola, that this is going to form a parabola. If we wanted to, we could find the vertex. Just saving time on that, the vertex would be at 0, -1, and we can use old math that we know previously to find that. And the graph would open up like this, and that would be the graph of x plus 1 times x minus 1, and I'm going to write that here. All right, without anything to contrast this graph to, multiplicity, you'd think, well, I don't need multiplicity to draw this graph. I could draw that graph way back at the beginning of the second 9 weeks. Okay, that's fine, but let's contrast that with this example here. Okay, so in this example, our function is x minus 3 times x minus 3. So finding the roots of this, again, same process. Set the function equal to 0. Use the zero product property. All right, we get x equals 3 for both answers to each of those equations. So does that mean that there's two different answers? No, there's one answer. But there's one answer, but it has a multiplicity equal to 2. All right, why is it 2? Well, because that solution shows up twice in the solution set. Or another way to state that is, we have two of the same factors. Right? This function could easily be rewritten as this. That little 2 in the exponent up there tells me that there's two factors of x minus 3, hence the multiplicity of 2. Now, let's graph this function. If we graph this function, okay, it has an x-intercept at 3. And if you remember way back, if there's only a single root, that means that that root is the vertex. All right, so drawing the graph. This isn't to scale, by the way, but drawing the graph would look like this. And you would have a y-intercept, just thinking real quick, 0 minus 3 is negative 3 squared. That's the y-intercept is going to be 9. Just plug in 0 for x to find that. All right, so we have a certain behavior now that we can see. There's a pattern here. Okay, when the multiplicity of a root is 1, the graph will pass through that point. If the multiplicity is 2, the graph will bounce off that x-intercept. Now with quadratics, we don't really need to know this information, but when we get to higher degree polynomials, so a quadratic is in the family of what's called polynomials, when we get to polynomials, you're going to need to know those behaviors, because when I start adding on factors, let's say I add in an x plus 2 squared, well, I'm going to be able to graph this using the fact that this root that comes from this factor has multiplicity 2, so it's going to act just like this graph did here, because there was a multiplicity of 2 on that x equals 3. All right, so that's going to be in the future, but that's what I'm setting you up for. I'm setting you up for understanding what multiplicity does on the graph. What is the behavior around the roots based on their multiplicities? All right, I hope this helps.